Good morning, Algebra 2. I know we normally don't have class in the morning, but I'm getting this done, so it's morning now, maybe afternoon when you're listening to this. So we're going to solve inequalities, rational inequalities today, and they're very similar to at least one of the ways we did solving equations on Friday. We're going to I have it listed out here. We're going to get everything on one side of the inequality, so we're going to have 0 on one side, the other side. And then we're going to combine everything into one single rational fraction. And we're going to leave it in factored form, hopefully, on the non-zero side. And then we'll be able to find undefined points from what makes the denominator 0, and we'll be able to find undefined points that make the numerator 0. And we're going to plot all of those on a number line, and that's going to determine where the signs change, or where the signs could change for the rational expression. And we're going to be looking for when it's less than 0 or greater than 0, so we'll be able to determine which sections are our solution regions. Okay, so I'm going to do this first example here on the left. Looks like we're going to need a common denominator of 9 and x. First, I guess I'm going to move the 5 over 9 to the left side, so we're going to have 4 over 3x. I'll leave myself some space here. Plus 7 over x minus 5 over 9 is less than 0. Okay, all I did was subtract the 5/9, so I left my inequality the same. I'm going to times this one by 3 over 3, times this one by 9 over 9, and times this one by x over x. So I'm multiplying each fraction by 1. The 1 looks different in each case, but it gives me 9x in every denominator. We have 9x here, 9x here, 9x here. So my numerator now looks like 12, that's the 3 times 4 here, plus 63, that's the 9 times 7, minus 5x over 9x, which is going to be 75 minus 5x. And I can factor a 5 out of that. Might be nice. Let's do that. 5 goes into 75 15 times. Okay. So, we moved everything to the left by subtracting 5/9. We made it into a single rational expression, and now we can look for where are the undefined points and where are the numerator zeros. Well, the undefined points are 0, and the numerator is 0 when x is 15. So on a number line, we know that the whole expression is 0 here, and it's undefined here, and whatever it is in this region between 0 and 15, it could be different. Well, it could be different in each one of these sections. There are times when it doesn't change from one section to the other. When I say each one of these sections, I'm referring to this region, and this region. So less than 0, between 0 and 15, and greater than 15. So I'm going to just pick a number. Well, let's start at less than 0. Pick a number less than 0. So let's say I pick -5. If I plug it into this expression up here, -5, 15 minus the -5 is going to be 20 times 5 is 100, so this is positive. And if I plug in negative 5 down here, it's going to be negative. A positive divided by negative, the whole expression is going to be negative here. If I plug in something between 0 and 15, let's say I plug in positive 5, again, the numerator is positive because 15 minus 5 is 10. 10 times 5 is 15. And now the new denominator is also positive because 9 times 5 is 45. So we have a positive divided by a positive, so the whole expression is positive. And if I pick a number bigger than 15, so let's say I pick 20, okay? 15 minus 20 on the numerator is going to now make that negative. And the bottom is going to stay positive because 9 times 20 is going to be positive. So now the whole expression is going to be negative because the numerator is negative and the denominator is positive. We are looking for negative, less than 0. So our solution is anything in this region and anything in this region. So we go to write our answer, we write it like this: x is less than 15, or, x is less than 0. 0, or x is greater than 15. And we could check those in the original problem. But that would be a lot of arithmetic, and I don't feel like doing that. Sorry. I feel pretty confident about what I did, so I'm not going to check it. But, well, I can see that if I pick a negative number for x, these are both going to be negative. 4 over something negative, 7 over something negative. I'm going to add those together, I'll get negative. That'll be definitely less than 5 ninths. If I pick something greater than 15, these fractions are both pretty small, so I can see how that would be something less than 5 ninths. I think I said greater than 5 ninths a minute ago. I meant less than 5 ninths. Okay, so let's try this again over here on this next example. Whoops. I'm going to first move everything to the left side since that's where more terms are to start with. And now I have it greater than or equal to 0. So now I can compare to positive or negative, which makes it much easier. Denominators are either x plus 2 or x minus 2, so I'm going to change them. I'm going to times this one by x minus 2, top and bottom. So it has both factors in the denominator. I'm going to times this one by x plus 2, top and bottom. So it has both factors in the denominator. And this one also by x plus 2, top and bottom. So my new common denominator is now x plus 2 times x minus 2, and that's still there. Now, the numerator, let's see, first term here is going to be x squared minus 4x plus 4 plus, that's this plus, x plus 2, because that's times 1, minus, again, that's this minus, and then I'm going to multiply these two binomials together and give myself x squared minus 2x minus 8. Okay? The nice thing is, it looks like x squared minus x squared, those cancel out. Oh, this should be in parentheses because it's minus that whole term. Let's see, what else do we have? We have a minus 4x. We have a plus x, so that's minus 3x, and then minus a negative 2, so that's plus 2. So 3 minus 4 is negative x. We have 4 plus 2 is 6, plus, because minus and minus 8 is 14. see if I did that right. 6, 8 is 14, minus 4, 6, minus 2, minus 1. Okay. So again, once we get it to a single rational expression, I'm going to look for what are the zeros in the numerator, what things make the numerator 0. So I could set it equal to 0, but in this case I can see x equals 14 will make that 0, because negative 14 plus 14 is. And what will make the denominator 0, which are undefined points, are going to be x equals 2 or negative 2. So I'm going to make a number line. And I'm going to go negative 2, positive 2, we have 0 somewhere in the middle, and somewhere out here is going to be 14. And this is where it's going to be 0, 14, and it's going to be undefined at 2 and at negative 2. So I want to pick a number smaller than negative 2. So again, I'll pick negative 5. I can pick negative 3. Yeah, let's do negative 3. If I plug negative 3 into the top, I'm going to get positive 17. If I plug negative 3 in down here, this factor will be negative. But, actually, excuse me, both will be negative. Negative 3 plus 2 is negative 1, and negative 3 minus 2 is negative 5. So negative times a negative, that whole denominator is positive. So the fraction, the rational expression, is positive in the numerator, positive on the denominator, so the whole thing's positive. At 0, which is between negative 2 and 0, negative 2 and positive 2, the numerator is going to be positive still, and the denominator is now going to be negative, because this one will be negative when x is 0, and this one will be positive, and a negative times a positive is a negative. So now the numerator is positive, the denominator is negative, so the whole rational expression is negative. When x goes greater than 2, so we'll pick a number over here, say like, oh, let's pick 10. Numerator is still positive because negative 10 plus 14 is positive. And now everything's positive in the denominator. 10 minus 2 is positive, and 10 plus 2 is positive. So we have positive divided by positive, so this one's positive. And when we go past 14, the numerator, the top, becomes negative, because if we have a, say, 20, negative 20 plus 14 will be negative. But again, the denominator is all positive, because if we add 2 or subtract 2, we're starting with something bigger than 14. We're going to have positive. But when the rational expression has negative in one and positive in the other, the whole thing's negative. In this case, we're looking for greater than or equal to 0. So we're looking for the positive sections. So my solution is going to be less than negative 2, or between positive 2 and 14, which looks like that. And there's my solution. Looking for positive, greater than or equal to 0 is positive. Positive happens in those two sections. Now, you'll notice that on both examples I did, every time I crossed one of these dotted lines, it changed signs. Positive, negative, positive here, then it became negative, then it became positive in the next section, then it became negative again. That will normally be the case. The only time that won't happen is when you have a factor that shows up twice. So like if one of these factors in the denominator had been squared, or if the same factor showed up in the numerator and the denominator. Because what happens then is two things change sign, and if two things change sign, probably the whole thing doesn't change sign. And so that's why we kind of need to check every single little section, but it's pretty easy. Think of what happens when you plug in a number into one of those little expressions. Once you get it factored, all you're plugging into is each of these little things, and you're determining whether they're positive or negative, which is pretty easy. Okay? So that's the whole process. You get it so that you have 0 on one side, so that we're comparing to 0, the positive or negative. That's easy. We combine all the terms to make it a single rational expression, factored form. Okay? Then we find all the undefined points, or the denominator zeros and the numerator zeros, put those on a number line, and then find the sign of each section, and then determine which one of those sections is our solution based on the original inequality. Like in this case, where we were looking for positive because it was greater than or equal to 0. Oh, greater than or equal to 0. So that would mean that these would be or equal to in my final solution. Whereas the other one was strictly less than 0, so I was only looking for the negative regions, like here, like the left and the right. Okay? Hopefully that will help. There's the new assignment, page 515, 12, 14, 26, 28, 30. Please be sure to like and subscribe.